Welcome to Chapter 12, Section 8, called Triangles and Coordinate Proof. This is for Integrated Math 1 or IM 1. So just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt, because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. New. Okay, so determine whether a triangle with the given vertices is a right triangle. So one thing they want you to do in here, and it's been a while since we've actually dealt with this idea, but when we're dealing with slopes, we have a right triangle like this, which would mean that the slopes are perpendicular to each other. So this line is going to be perpendicular to this line. And that means that the slopes are negative reciprocals of each other. So that means if this slope, and I know this is straight up and down, this is horizontal and vertical. So we have a horizontal line, a vertical line, but it doesn't necessarily mean I could have them like this, and that could be my right angle there. So they wouldn't necessarily be horizontal and vertical. That's definitely not a guarantee on your if we actually went through and plotted these. But what we would want to see is the negative reciprocal. So let's say if one had a slope of 1, the negative reciprocal would be -1 because they're both over 1. So it'd be 1 over 1 or -1 over 1. Technically, the -1 would be on the bottom, but it would move up to the top when we reduce to 1 over 1. Or let's say that it had a slope of 1/2. Well, the reciprocal would be 2 over 1, or just 2. It was positive, it would turn to negative, like that. Or if it was -1/2, it would flip over just like that, but it would go from negative to positive. So we have to pay attention to that negative reciprocal idea, but what we need to know is the slope. So we're going to use the slope formula here. So we're going to use the slope for each one of these. We're going to calculate what the slope is for each one of these lines. Remember, we have a triangle. We have 3 lines in each one of these. So we have to do the slope formula 9 times to check all of these, because we need to determine, are any of these negative reciprocals within part A, within part B, within part C. So For this one, I have PQ, and I want to know what the slope is. So I'm going to do rise over run. And I actually do this. I'll show you kind of the way I do this in class. I go like this, 5 over 8, and then -3/6, like this. I've actually just stacked them. So I have my x's and my y's, and I go and I subtract straight down. So I have 8 minus 6, and that gives me 2. 5 minus -3, that's 2 negatives, so that's actually a plus. So that's 5 plus 3, which gives me 8. So now, remember, this is run because it's the x's, this is rise. So I'd have 2 over 8, which would reduce down to 1/4. This is the exact same thing as doing the slope formula, so I'll also show you the slope formula real quick. So we have QR, if I do just the next piece here, QR. So I'd have the y's, the change in y over the change in x, which means y2 minus y1, so 10 minus 8 over x2 minus x1, so I'd have -5 minus 5. -5 minus 5. And if you notice, if I'm stacking them, I'm doing the same thing. y2 minus y1, x2 minus x1. It just depends on, maybe that makes it a little easier so you don't have to identify those. They're just already stacked in order. I've seen students, they like both of these. Just depends on the student and which one makes a little bit more sense. So I have 2 over -10. So I end up reducing that to -1 over 5. So far those are not the same because we'd need 1/4 and then -4. Or I'd need, this is -1/5, so I'd need +5 to be a negative reciprocal. All right, so the last one we're going to do is RP. And I'm going to go ahead and stack my pieces here just because for whatever reason I like this a little bit better. So I have -3/6 and -5/10. So I'm going to subtract. So I have 6 minus 10, and that gives me -4. -3 minus -5. So remember, this is going to turn into a plus because it's minus negative. So I'm going to have -3 plus 5, and that gives me 2. This is run. This is rise. So I end up with -4 over 2, which gives me -2. 4 divided by 2 is 2, and so it's negative. None of these are negative reciprocals of each other. So this is not a right triangle. You're not going to say it cannot be determined. They are 3 sides to a triangle, and we're going to assume it says determine whether a triangle with the given vertices is a right triangle. So we're not assuming that it's not a triangle. It is a triangle. We're just deciding is it right or not right. And either there's going to be a negative reciprocal or there isn't. So that's all we're looking at or looking for here. So we're going to do the same thing for DE. All right, so we have DE, so we have 6, 0, and -5, 5. Let's subtract straight down, so we have 0 minus 5, that's -5. 6 minus -5, remember that turns into a plus, so we end up with 11. So then we end up with -5 over 11. Can't really reduce that, so we're just going to leave it alone. And then we're going to do EF. So I have -2 over -3 and 6 over 0. No, I didn't cross off my zeros there. So I end up with -3 minus 0, which is just -3. -2 minus 6, which is -8. So I end up with -3 over -8, which turns into 3 over 8. 2 negatives make a positive. And then I have FD. So I can go -2, -3 over -5, 5 minus. So -3 minus 5, that gives me 8, 9, 10, 11, -11. Sorry, 5, 6, 7, 8. I don't know why I said 11. I counted 8 and then 3 more. So that gives me -8. And then this is -2 minus -5, so that's a plus. So this ends up 3 positive. So this ends up -8 over 3. This was positive 3/8. This is -8 thirds. Those are reciprocals. They're flipped over. One's positive, one's negative. That is a right triangle because these two are perpendicular to each other, which means that they are a right angle. All right, I'm going to erase this so that I have room. Do that last guy there. So now we're going to go A, B. We're going to have 9, so 1/5, and -9, 5. So 1 minus 5 is -4. 5 minus -9, remember that turns into a plus, so this ends up being 14. So I have -4 over 14, which reduces. They can both divide by 2, so I'd have -2 over 7. Now I'm going to go B, C. So I end up with 9, 5, -7, 12. 5 minus 12, that gives me -7. -7 minus -7, sorry, -9 minus -7, that turns into a positive, so this turns into a 2, a positive 2. So let's see. This ends up being -7 over 2. So there are reciprocals of each other, but they're not negative to positive. It's negative and negative. So these are not perpendicular to each other. And I need to make sure that I didn't mess up the negative there at all. So I end up with negative, I end up with positive, so that's fine. I end up with negative, I end up with, oops, this should be negative. -9 plus 7, so this should be negative. So this ends up being 7 over 2. So these are negative reciprocals of each other, so it is going to be a right triangle. I don't even need to check that third side because we're not going to have two sides or another side of the triangle perpendicular because that would mean we have more than one right angle. So we can be all done. Check. Yay! So again, we're just checking slopes. I know it takes a little bit longer to go through and check all the slopes because we have to do each and every one. Okay. So we're going to do isosceles triangle. EFG is shown. Give the coordinates of F. And so with this one, I know on the notes diagram, when I did this in class, it was actually more diamond looking. So, you know, just adding another triangle down here. But as long as we're kind of thinking through, they do give us some pieces here. So I'm going to go ahead. You know what? No. I'm going to save it real quick just in case I need to bring that back. And I'm going to give myself a new one because we don't need this one up here right now. But I didn't want to completely erase it because then I'd have to redraw that if we need it later. So I'm going to go like this just so that I can draw this. So I have 0 and R. This is my coordinate up here. I have -Q and 0. So even though it's Q and R, well, what they want us to do is fill this piece in here. So we need to think about a couple properties for an equilateral or an isosceles triangle, not equilateral, but isosceles. So isosceles means that these are the same length, right? They already show us that. These are the same exact length. If we have an isosceles triangle, though, it's the same length. If I go straight down, which is actually the axes here, it's going to be perpendicular to the bottom, and it's going to cut it in half. So I know that this length is going to be equal to this length on this side. And that's just one of those properties of an equilateral triangle. It has to do with the perpendicular bisector. So I know it's perpendicular, and because it's equidistant from the endpoints here, they're the same distance. I know it's a perpendicular bisector, meaning it's going to cut that line in half on the bottom. So I'm kind of combining a couple of things there as far as definitions. And definitely when we're in the geometry sections here, it's very important to kind of study and make sure that you're paying attention to all these different definitions and postulates and theorems and all these things that come up because we reuse them constantly. So the more you study them, the easier this becomes, just because it's easier to recall the more we look at them. All right, so if I know that this cuts it in half, and this is my 0, 0 mark, by the way, this is the origin of the graph. Well, if I'm going left negative q, so that's what negative q means, I went left q. I don't know what q is, but it stands for a number. So if I went q units to the left, I'm going to go q units to the right, but it's going to be positive, right? Because it's positive, it's right. It's negative because it's left. So I'm just going to have q here. So I've already filled in part of my coordinate for f. Now I need to know what is my y-coordinate. Well, I'm on the x-axis, aren't I? So the x-axis, if it's on the x-axis, I'm not going up or down at all. It's just going to be 0. So it's just a matter of kind of looking at it. What do I know about this shape? And how can I use my knowledge of this shape and other properties of, lines and isosceles triangles and things like that? How can I use these properties to get what I need to solve this problem? And I know we do something very, very similar when we were doing the rhombus, which is the diamond type shape. We actually had 2 coordinates to fill in on that one. So we filled in the coordinate just like we did here, and then we also filled in another coordinate at the bottom. So it's just another one of those, filling in pieces. If we were to do that here, now we would be on the y-axis down here if we were to fill in a diamond. So we would still have 0 for x because we didn't go right or left. And we would use that same idea. If I went q this way, I'd go q this way. Well, if I went r up, I'd go r down. Because a rhombus, especially if they tell you that it's a rhombus, which they did on this one, they told me it was an isosceles triangle on this one. By this one, sorry for the first one, I meant the notes page. On a rhombus, that means that all sides are congruent, which we can think of the very basic rhombus of a square. That's the idea. But rhombuses can be more squished and look more like a diamond. All right. So let's go ahead and keep going here.